Hi guys, in this video I'm going to go through one of the most difficult exam questions I've seen in binomial PD, using the binomial PD function. I'm sure you guys have seen the expression, the probability of x equaling r is equal to n choose r multiplied by the probability to the power of r multiplied by 1 minus p to the power of n minus r. And we're going to use this to form two expressions and to find n in terms of p. So let's go about doing it. First of all, the probability of x equaling 4 according to this expression, all we're doing is replacing r with 4. So we have, there's another alternative equation which I want us to sort of use here. N factorial multiplied by, all divided by n minus r factorial multiplied by r factorial. And then p to the r, 1 minus p to the n minus r. And let's go about how to use this. So we don't know what n factorial is right now. That's one of the things we're trying to represent. So let's write n factorial over, well, we know r is 4 for this question. So n minus 4 factorial multiplied by 4 factorial. Times the probability that we don't yet know to the power of 4 multiplied by 1 minus p to the power of n minus 4 is equal to everything here except when we replace r with 5 now instead of 4. So everywhere where there's a 4, we're just replacing it with a 5. So let's do that on the right hand side of this expression. So n minus 5 factorial. Yep. 5 factorial p to the power of 5, and then this will become 1 minus p to the n minus 5. Okay, how do we simplify this and make it so that n is in terms of p? Well, you want to cancel out as many terms as you possibly can. To start with, we can divide both fractions by n factorial. Not only that, 4 factorial, if you put that into your calculator, well, actually, even a better way to think about it is we can multiply both sides by 5 factorial, because 5 factorial over 4 factorial, well, 5 factorial is 5 times 4 times 3 times 2 times 1. 4 is 4 times 3 all the way down to 1. So that will just equal a numerator of 5. So not only will that make the numerator of this fraction 5, so it becomes 5 over n minus 4 factorial, it will cancel out the 4 factorial in the denominator. And the reason I specifically chose that factorial, just realized there's a 4 there, is because when you multiply the right hand side by 5 factorial, it'll cancel out the denominator here, leaving you with 1 over n minus 5 factorial, p to the power of 5, 1 minus p to the power of n minus 4. Great. What else can we do to simplify? We can divide both sides by p to the power of 4. I'm not going to bother writing that out again. Instead, we can just cancel out p to the power of 4 here and leave p to the power of 1 on this side. The only reason we're able to do this is because there's only one fraction on the left hand side and one fraction on the right hand side. So we're doing it from each of the two individual terms, if that makes sense. We can also simplify the n minus 4 factorial and n minus 5 factorial. To think about this, I'm going to substitute a random number in to help you guys understand it. If you put n equals 10 into this, the denominator specifically, I'm not going to exclude the 5 for now. I just want you to focus on the denominator. It becomes 1 over 6 factorial, whereas this one, when you put n equals 10 into it, it becomes 1 over 5 factorial. So essentially, if I multiply by, I'm trying to say as less as possible. If you multiply by 6 factorial to both of them, it'll become just 1 for this term and just 6 for this term, won't it? Because 6 factorial over 5 factorial is 6. So what that means is when you multiply by n minus 4 factorial, it will cancel out with this one, but it'll also cancel out with this, but it'll leave n minus 4 on the numerator of this, using this theory that I've sort of just shown you. If you want, you can rewind that because that was quite difficult to grasp. But what we're going to do is multiply n minus 4 factorial to both sides of the equation. Like I mentioned, it cancels out with the n minus 4 factorial that's already here, leaving you with 5 lots of 1 minus p to the power of n minus 4. But on the right hand side, n minus 4 factorial over n minus 5 factorial. Well, n minus 4 factorial is n minus 4 times n minus 5 times n minus 6. So it cancels out with all the n minus 5 factorial terms, leaving you with just n minus 4 on the numerator. Multiplied by p, multiplied by 1 minus p to the power of, and I made that mistake again. Should be n minus 5 here. Sorry, it's a lot of n's and p's. Okay, how do we go from there? Well, from there, you can now multiply both sides by 1 minus p to the power of n minus 5, I believe would be best. Because that not only cancels out this, but when you multiply these two terms together, let's write that out separately. We have 1 minus p to the power of n minus 4, and if you multiply onto that, this, Oh, how about we divide by it actually? I think it might be better if we divide by it. I'll show you why. If you divide by 1 minus p to the n minus 5, that will cancel this out. Sorry, multiplying doesn't really cancel it out. If you divide by it, let's do that to the side. We have 1 minus p to the power of n minus 4 already there. And you're dividing it by 1 minus p to the n minus 5. Because the base is the same, you're essentially subtracting the powers. So you have n minus 4 take away the power of n minus 5. So expanding that out the minus, it becomes minus n plus 5. Minus 4 plus 5 is 1, and the n's cancel out. So that will leave you with 1 minus p to the power of 1, which is what we want. So now we'll have 5 lots of 1 minus p all to the power of 1 equals n minus 4 all to the power of 4. Okay, now we finally put into a format where it's a lot easier to expand out and solve for n in terms of p. So let's do that. First of all, expanding out the brackets, 5 times 1 is 5, 5 times minus p is minus 5p, n times p is np, and minus 4 times p is minus 4p. Let's take all the terms with n to one side and all the terms that don't have n to the other side. Just thinking if I missed out something. Okay, let's add 4p to both sides. So we have 5 minus 5p plus 4p is minus 1p is equal to np. And then you want to just divide both sides by p to get n in terms of p. So it becomes 5 minus p all over p equals n. Or if you want to separate this into individual fractions, it can be written as 5 over p, take away p over p, which is just 1. And that's your final answer for this question. Like I said, you could have also written in this format, but either one is correct. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.